Hi, and welcome back. So in this video, we're going to do another Calc 1 final review problem, and we are going to take a look at the limit as x approaches 0 from the positive side of e to the x divided by the sine of 5x. So now, one of the things, so anyway, this is the problem if you want to pause it, and I'm going to assume you've unpaused the video now. So the first thing, and this is probably the first thing that I should have been saying in the past final review problems when we've had limits, but the very first thing that you should think about when you see a limit problem is checking to see if we have one of our indeterminate forms. Indeterminate forms. And if you remember, I'll just write down two of the most important indeterminate forms that you could have, and two of the indeterminate forms that you're going to see most often when you see these limit problems are going to be either 0 over 0 or infinity over infinity. These are the two forms. These are the two, I guess, indeterminate forms that when you see them, something should go off in your head and say, oh, well, I'll bet that this limit actually approaches something. So the very first thing to do with this limit is let's try to figure out if we have our indeterminate form. So I'll switch colors. So what is, and the way we figure out if we have our indeterminate form is we just plug in this number as x approaches it. So we figure out, so as x approaches 0, what does e to the x approach? Well, we just plug in 0 for e to the x, and e raised to the 0th power, or anything raised to the 0 power, is just going to be 1, right? So we've got 1, and how about the sine of 5x? What's that going to be? Well, it's 5 times 0 is going to be 0, and the sine of 0 is just 0, right? So now you should hopefully see that we don't have our indeterminate form. We don't have our indeterminate form, so our limit isn't going to approach a finite number. And what is, and this is one of the things that we hopefully saw the video earlier on in the playlist, but if you didn't, you can go and review it. But when we have a limit that approaches, we have a finite number over 0. So when we have a finite number divided by 0, our limit is going to be infinity. Our limit is going to be either positive or negative infinity, depending on which side we're approaching from. So now you can think, okay, well, we're approaching 0, 0 from the positive side, right? That's what this limit is telling us. So as we approach e, as we get really close to 0 from the positive side, and hopefully you can see even with e, if we approach 0 from the negative side, are we ever going to have a negative number? Are we ever able to get a negative number when we raise e to any power, when we raise e to -1? Well, that's still going to be a positive number, right? Even if we raise e to the really, really, really small positive value as we get closer and closer to 0, we're still always going to have a positive value, right? So we're going to have positive values in our numerator. And how about, what are we going to have in our denominator? Well, if we were coming from the sine, and let me actually, you know what, maybe I'll just draw a small unit circle right here. So remember that our sine is going to be this y-axis, right? It's going to be our y value. And the angle that and essentially what our sine is this y value depending on some angle we put in, right? So anyway, if we had a really small positive value, so if we had, and maybe I'll even draw, here I'll draw this. Actually, you know what? I just realized I can draw I can draw really nice looking axes now, so I'm going to actually do that. So there, if we had a really small angle, so if we had something like this, that's a really small positive angle, which is what we have. This is our y value, right? And that's still going to be positive. How about what would happen if we had a really small negative value? Well, then we would have a really small, actually, you know what? I've also got a straight line tool. I'm going to use the straight line tool. So there, that if we had a really small negative value, it would come down like that. And then this would be our value for the sine, right? It would fall on the negative side of our y-axis, and that would be negative. But we don't have that, right? We've got a very small positive value because we're approaching 0 from the positive side, right? So therefore, what this is going to be is we've got our positive number, and we've even got positive 1, divided by really small, actually, you know what, I'll write this in. So we've got positive 1 divided by really small positive numbers. So hopefully you can understand it. I'll just, this is maybe the written word version of what I'm trying to get across. So we've got a positive 1 divided by really, really small positive numbers. So as we divide something, as we divide a finite numbers by numbers that get really, really small and really, really close to 0, this is going to go to positive infinity. Let me draw there infinity. This is going to go to positive infinity, right? And even, you know what, actually, you know what, I'm not going to graph this one. This might be a good exercise for you to graph on your own, or hopefully you've been graphing a bunch of stuff from this playlist on your own to, check the answer. And this is even, like I've been saying, it's a good thing to maybe wean yourself off of checking to make sure that you got the right answer and feeling very confident. But this is, like most stuff in a Calc 1 class, you can figure out whether or not you got the right answer by just graphing it and using some graphing application rather than, having to look in the back of the book. And this is definitely one of those problems where you can do that. But anyway, that's our final answer. Our final answer is that this function, as the limit as x approaches 0 from the positive side of e to the x divided by the sine of 5x, is going to be positive infinity. So hopefully you found that useful, and in the next bunch of videos I'll just keep doing final review problems. Thanks for watching.